So let's start with this session about MicroK8s and how it is fully integrated with AWS. Together with me, Berkay Tekin is going to do the presentation about the integration and the capabilities and how to set up. Myself, Dalton Ruiz, engineering manager for MicroK8s, I'm going to give a bit introduction of what is MicroK8s for those people that are new into this product. The agenda for that we have for today, it is like a small intro. I'm expecting that not to be more than 4 or 5 minutes. And then we will get into the content, starting with why MicroK8s integrated with AWS, and then setting up EKS, IAM, EBS, EFS, and ELB. Discussing about the calendar. So first of all, you can find us in this community hour every Friday, 1:30 GMT, and here it is a link for the participation. The next session we are going to have for sharing, it is on 3rd of February, and then we're going to summarize all the advantages of the feature that we have released with MicroK8s 1.26. Session after, 17th of February, we're going to talk about MicroK8s on Cluster API. MicroK8s is on Cluster API since 1.26. So that will be a very interesting session. And 3rd of May, we are planning to talk about hardening security with MicroK8s and with focus on what we can do on a strict confinement. Where you can reach us, MicroK8s.io website, we have a lot of documentation there about how to. In our GitHub at Canonical MicroK8s, basically everything we do is recorded there, and then this presentation you can find it in Berkay's profile in GitHub under this link. If you want to reach out for discussion, we are present on Discuss Kubernetes.io with the tag MicroK8s, and also in Slack, and then you see here what is a link for the Slack meeting. If you have any issue that you want to discuss or you want to get orientation, recommendation related to MicroK8s, you can go to report the issue on GitHub at Canonical MicroK8 issues. However, this is community support, so it is not a professional support. If you have a production workload, I recommend to have support from standard Canonical support channels. And now, what is MicroK8? So it is a lightweight Kubernetes solution that especially can run on devices with resource constraints, so very lightweight, and this is able to run where other Kubernetes solutions cannot. However, it has all the Kubernetes services and then a big set of add-ons. So we have today more than 40, and those are like Kubernetes modules or applications that you can run with the MicroK8s. It is zero ops for easy clustering, and one of the most important features, it is production grade ready. We have self-healing and we have high availability. So any production workload can be run on the MicroK8s. We have automatic updates and upgrades, so happening on the background, and the customer doesn't need to pay attention to that. And then we are secure by default, but we have hardened the security, and this is one of the sessions that we are going to have in the future, where we are going to explain how to use MicroK8s with strict confinement, and also airbag, and then also the long-term support that we are bringing in Canonical for MicroK8s. We have got the question several times on when to use MicroK8s and when to use Charm Kubernetes. So Charm Kubernetes is another Kubernetes distribution that we have in Canonical. This is a full-fledged of the Kubernetes, and this is able to carry a lot more payload than MicroK8s. And for that reason, this is thought to be run on private clouds and also on public cloud. MicroK8s, this is a very lightweight, is able to fit into any edge device with resource constraints, for example, anything related to IoT, and also recommended for microcloud, where you want to have a small Kubernetes solution that is fitting into your use case. The add-ons is one of the most important things that we have in the MicroK8s. So you can even create your own add-ons and incorporate it to the add-on ecosystem that we have. And it is, in order to use it, it is as simple as MicroK8s enable add-on, and you have the add-on running already. If you want to find more information, it is on MicroK8s.io/doc add-on. And then what you are going to find there, it is like two types of add-on. The first one is called add-ons. We have today about 20. And those are the add-ons that are maintained by Canonical, everything, including MicroK8s and the add-on. And just an example, we have Helm, Minio, CubeOVN, CoreDNS, and then many more. When it comes to community add-ons, those are the add-ons that community is preparing, and then we are integrating that with the MicroK8s. We have plus 20. And then just to mention a few, Multus, Cilium, Kubeflow, GoPaddle that we released in 126, and many more there. So if you want to see what is available, please reach out to this link in this slide. And now, Berkay, if you want to take.
Yeah. So let's talk about what is EKSD. So EKSD is a Kubernetes distribution from AWS based on the Elastic Kubernetes service they offer to create reliable and secure Kubernetes clusters. Why use MicroK8s with EKSD? Well, MicroK8s makes deployments of EKSD easier and adds all the benefits of MicroK8s, such as easy clustering, automatic patch updates, officially maintained core add-ons, community add-ons, and AWS-specific add-ons. So EKSD, how does EKSD differ with vanilla Kubernetes, you might ask? Well, EKSD has extra specific security patches and has a different maintenance cycle than vanilla Kubernetes. So currently, the latest EKSD version that is out is 124. So they are supporting older versions of Kubernetes for some more time with security patches. With MicroK8s, we bundle the EBS, EFS, ELB, and IAM add-ons, which enables the MicroK8s cluster to integrate with required storage resources, load balancer resources, and authentication resources. And this basically provides the familiar experience to get using the Elastic Kubernetes service, but with MicroK8s. So there are some deployment comparisons we can look at, which is what if we want to deploy EKSD manually? What if we use the managed service from AWS? And what if we use the MicroK8s EKSD tracks? So to get a manual deployment of EKSD, you can deploy this on any cloud or even on premises. You will get all of the benefits of EKSD, like the extended security patches, but this requires manual deployment and management, which is a tedious task to do by yourself. There is no tool like kubeadm to take care of this properly. If you want to let AWS do your management for you, you can use the Elastic Kubernetes service. This is basically with the same benefits of EKSD. The management and deployment is done via AWS, but the deployment is restricted to the public cloud, and it has some cost attached to it. But with MicroK8s EKSD tracks, this whole deployment is managed by the MicroK8s Easy Clustering. It includes the extended security patches of EKSD just the same way. Can be deployed in any cloud or on-prem. It has the additional add-ons from core and community, and it is much more price efficient compared to the other alternatives. So before going to questions, I will start with the demo. So I will pick up from the CloudFormation template we have. So for our demo, we have a CloudFormation template, which is used to get resources, manage resources on AWS, which is needed to let our add-ons such as EBS, EFS, ELB, and IAM work. They require some specific resources with specific configurations. So this CloudFormation template has all of them in there and configures this for us. We will start provisioning this, and then I will explain what CloudFormation template has, why it is required while it is provisioning. To get started with this, we will go to the AWS CloudFormation page. We will create a stack by just saying create stack. I can make my screen bigger. I think it might be a bit small. So we will choose upload a template file, and let's choose a file which is for me under the demo page. When we select this, we can continue on with the deployment. So this will ask us for some stack details. We will give a stack name such as MicroK8s test. There are some pre-configured parameters for the subnets. This is required for the load balancer add-on. You can change this however you like with some constraints, but leaving the defaults are just fine. So the AMI ID is just to get the latest Ubuntu AMI ID from the AWS public cloud. We will just deploy on 2-core 4 gig M4 large instances. We will need to put our public key to gain access to the cluster. So I have my public key here. I will just use it for that. And then we will need to supply our user ARN that we want to use for the IAM authentication. So to get that, we can go to the IAM users and choose the user we like. And then we can get the ARN from that page. I will use my administrator user's ARN. And then we will supply a cluster ID, which I will leave as default, which is MicroK8s. And then we will just continue on with the deployment. There is nothing that we need to do beyond this stage if there are no preferences by the user. So it will show us the parameters that it's going to be deployed with. It will acknowledge that it's going to use some IAM policies, require some elevated permissions, and then we will submit. So the stack should be getting created. I think we can see our resources. There will be resources that's going to be created with some time. Meanwhile, we can go over the CloudFormation template and what it does. So basically, for most of this part, it will define some parameters with defaults, such as the subnet blocks, the public key, the node instance type, the user ARN, the things that we just configured through the UI. Other than that, for resources itself, it will create a VPC, a internet gateway, a gateway attachment, a root table, all of the necessary VPC setup that needs to be there to get an operational cluster that can use the load balancing capabilities. So for that, there will be some hard requirements. You can use the load balancers either in a public subnet or a private subnet. And for that, the ELB add-on requires you to have 2 subnets of each type. So it's going to be public subnet 1, public subnet 2, private subnet 1, and private subnet 2 with some configuration. The configuration is basically some tags that we need to use, which tells the cluster, okay, you can use this for load balancing, right? So we tag it with kubernetes.io role ELB, and if you give the value 1, it will know to use this subnet for getting the load balancer in there and opening up to the, if it's public, to the internet. If it's private, it's just going to keep it in there. As you can see, when you say ELB, it's a public load balancer. You can, for private subnets, just say kubernetes.io role internal ELB, and it will be just for private subnets. So this is the configuration that's required by the add-on, but the CloudFormation template more or less sets the whole VPC and the subnets up for us. If we continue, we will have some security groups that will enable SSH connections. And starting with the policies, we have the EBS CSI policy, which is required to manage our node, so it can create volumes and attach volumes. If we choose to not use the user secrets, we can provide a user secret that can do these things to the EBS add-on, a key ID and a AWS secret, which will do this basically using that secret, or we can attach a policy to our nodes and enable our nodes to do these actions, such as like attaching volumes, detaching volumes. For the EFS, we have the EFS add-on. For file systems, it's the same thing, more or less. But instead of using secrets and key IDs. The EFS add-on only works with the node having a managed policy. So we attach the managed policy to the node. For ELB policy, we have the same thing. We will need some actions that the node should be able to do so it can provision load balancers and attach them. And these policies are just get compacted into a role here, which is a node role that we attach. We give the container registry read-only, so we can read some, we can get some images from the Amazon AWS container registry. We just create a node profile, instance profile, so we can attach it to our instance. We create a role to be used for our IAM authentication, which is called like tag name Kubernetes admin. You can configure this however you like. It will be for this CloudFormation template through the class to the stack name that we give for the CloudFormation template. We also set up some security groups. For example, EFS needs 2049 to be open through the for EFS and the node. So we will attach this to the node and the EFS. Again, for ELB, it requires 9443 to be open through TCP for any IP. So it can attach the ELB, so it will do some webhook calls through this port. And then we create a file system. We create a mount target and get this mount target based on our public subnet. We create a key pair. We just import our public key. It will be used for accessing the node. And we have a node that we define here, which basically gets the key pair, configures the instance profile, instance type, the subnet, the security groups, gets a 100 gigs of GP2 volume for the drive, and then has a pre-configured cloud unit script, basically. It just sets up the environment for testing. So it gets the AWS CLI, kubectl, gets the IAM authenticator binary so it can communicate with the IAM API to validate our kubectl calls. It just sets up the environment, basically. And then for outputs, it will just give us our node public IP, EFS ID, and Kubernetes admin arm, which will be used for our add-ons. So when we check our resources, I think it should be created. So for our outputs, when we check it, we will have the, let me zoom in a bit, EFS ID, the admin arm, and the node public IP. So from this point, our node is set up and should be up. We will need to set some environment variables there. And for this reason, I have a script which will import my access key ID and secret access key, which will be used for the IAM authentication and necessary EBS add-on to be enabled. So I will just call this script with the IP. So get IP from here, and in here, I will just call and it's going to copy our manifests that we have for testing, which has some basic pods and PVCs to test the add-ons that we will enable. So when we get that script done, we can just SSH into our node. So as you can see, we have our manifests under here. And to start off, we should install MicroK8s. So it's going to be sudo snap install MicroK8s. We will specify a channel, which is going to be 124-EKSD, and we will get the stable one. This is the latest EKSD version that's out right now. 125 is, I think, under testing, so it will be out, I think, close to the next release of vanilla Kubernetes. And this is a classic snap, so we will say it's going to be classic. This is going to download and set up MicroK8s for us. So I think it's going to be up soon. Might not be ready yet. Let's see the status. Okay. All right, it's booting up. We'll have to wait a bit. So in that sense, I can talk a bit more about how these add-ons will enable our cluster. We use the block storage for more or less anything storage heavy that's done on AWS, which is like if you want to run a simple, not simple, but like any database workloads or anything that requires a heavy use of storage, EBS is the more performant option, but it is only read-write once, which means you can only mount a single volume to a single pod, so you won't be able to use it across many pods. If we need something that has read-write many, which is basically can be mounted to multiple pods and can be read and written from multiple locations, we will have to use EFS. It's a file system from Amazon, which will enable us with anything that we need to share between our pods, more or less. And for ELB, this is basically to open our applications through AWS to the internet and load balance it properly. So in that sense, it will have some configurations, either private or public, as I said before. So I think our node is up. We can start with our add-ons. So first, I have some commands lined up here for our add-ons. We can start with the EBS CSI driver, which will enable the block storage on our cluster. So it's going to be a simple MicroK8s enable CSI driver. And we will have to supply with -k our key ID. These environment variables are set with the script we just ran at the beginning of this demo. So I won't hopefully leak my access keys. And when we do that, we can just hit enable. It will do some configuration, enable DNS for us, and afterwards enable the EBS CSI driver. So it created our AWS secret that it's going to use for the communication through the AWS API to manage resources. So in that sense, you can see that it is being installed. We have the daemon set here and the controller here. It should start soon. It's going to be a little bit of wait to get this started. And then we will continue on with testing the application, that it works correctly. Maybe I can make this a bit bigger. It takes a bit because we configured core DNS, which restarted kubelet. The cluster takes a while to get back up into its feed, so the pods should be starting soon, hopefully. Meanwhile, we can also enable the other add-ons before waiting for the EBS to be activated. So we can, the same way, enable our EFS add-on. It will be sudo MicroK8s enable AWS EFS CSI driver. And through -e, we will provide the EFS ID, which we have as the output of our CloudFormation stack. We can just put it down here, and then it's going to enable the EFS CSI driver. So let's see the status of our cluster. So as you can see, EBS node pods are started up and EFS is starting up. So let's finish enabling all of our add-ons before we continue. For ELB controller, it's again MicroK8s enable AWS ELB controller, and we will provide the cluster ID we used at the start of the session. By when we are creating the CloudFormation template, we gave it a cluster ID, which we used MK8. So I will use that and enable it. Okay, the next one is our AWS IAM Authenticator, which you can just enable by, again, MicroK8s enable AWS IAM Authenticator. Although we will need to do some configuration in the config map for the IAM Authenticator to work properly. So it's going to take a while to get the daemon set up. Do we have a question or? Oh, okay. Cause that to drop.
No, I don't think so.
Yeah. It takes a while to get the image and get it up. So the daemon set is up. Now it's going to configure the API server. So it will use the IAM Authenticator. And it is enabled. Now we can check the status of our cluster. And we should see that the EBS, EFS, and load balancer pods are up. Since we restarted our API server, our Calico and Core DNS pods are not ready, but they should be fine in a moment. Yes, and everything is up. So now we can go ahead with how we can use these. Under manifests, we have some YAML files that will create a pod, a volume to test stuff out for us. So they basically write the date every 5 seconds. So they don't do much, but it verifies that the volume is up and running with the pod is up and running with the volume, and everything's working fine. And we create a persistent volume claim to get a 4 gig volume from our EBS. So to do that, we can get into our manifest folder, and there will be our manifest that we have on our host as well. So MicroK8s curl apply -f, and we will start with the EBS. We will create a persistent volume claim, and we can see this by get PVC, which is in pending. It will get provisioned, and then this will update with the status of the volume that's going to be on AWS. Let's create our pod. And we can, MicroK8s, cuddle get pods. So it's going to be creating the container. I think our volume should be bound by now. As you can see, it is bound with a 4 gig capacity. We can verify this by going through our volumes tab in our EC2 dashboard. So as you can see, we have a volume of GP3 type for 4 gigs, which is created, and it's going to be attached to our pod here, which is running and should be outputting the date every 5 seconds into a text file. So this is for EBS. The way we use this is there are like storage classes. Basically, we can check them out by kubectl get storage class. We have the EBS storage class and the EFS storage class. These can be updated and changed the way the user likes. There are some policies we can change. For example, the reclaim policies delete for these. Maybe you want to use retain. You can just copy the same storage class and create another one. You can do MicroK8s kubectl get storage class. For example, let's get the EBS one. When you get the YAML file, you can see there are like the provisioner reclaim plus policy. You can copy this and create a separate one with a different policy and a different name, which then you can utilize. You are not just bound by these storage classes. We can continue on with the EFS. It's going to be the same way, more or less. We can apply our PVC, and then we can create our pod, which is basically the same pod that we have for EBS. It's just going to print some dates, and we can check that it is bound again for a 5 gigs read-write many volume, and we can verify this by going to our file systems, and we will have the file system here. I don't think it has gathered any data points yet because the pod is not up, but when the pod is up, you can visualize the connections and throughput that's going through the file system through this dashboard to verify it's working correctly. So let's check our pods. So our EFS pod is up. When AWS updates the metrics, we will be able to visualize that it's going to be writing some data there. This is basically for our storage solutions. We can get to the ELB next, which will be, again, you can check that we have some ingresses, services, and pods for ELB. We will start by creating our pod first, which basically creates a simple echo server. It just prints some information about the request and the system. We will create our service the same way and our ingress afterwards. So to visualize them, we can run MicroK8s kubectl get all under echo server namespace. So we have our pod, which is running. We get a service with the type of load balancer, which we can actually see through here. So we describe a service. It's going to be mapping a port to a target port in our container. We give the type of load balancer. So it's going to be a network load balancer in terms of the ELB controller. We will need to annotate this so it can be provisioned correctly through the AWS load balancer controller. We can type the schema, which is like internet facing. It's going to be external. It's going to be available in a public subnet. And the target type is instance. There is a different target type, which is supported by the load balancer controller. However, currently with MicroK8s, the only instance types are supported. The other type is the pod IP, which basically directly sends a request to your pod instead of coming to your nodes first and then directing them inside the pods through the node port. But that is not available yet because we don't have the AWS CNI available. So when AWS CNI is available for EKS tracks, the load balancer will also support pod IP types of load balancers that you can create. So we can also see our ingress through here, that it's going to have some address. It has been provisioned. To verify that, we can go to the EC2 dashboard and check the load balancers, which is in a provisioning state. After the provisioning is done, we can go through the URL and see that it is getting requests into the cluster. In the meanwhile, we can enable our IAM authentication. So to do that, we will need to change a file, which is the config map that we have for IAM authentication, with some values, which will be the cluster ID and the role arm. So we will update the cluster ID and the role arm so we can use that role to authenticate our user into the cluster. So to do that, we have the same manifest here, which I will edit. So our cluster ID was just MicroK8s. And for the role arm that we are going to replace, we have the output from our CloudFormation. You will just use that arm in here. And let's save this. So we will apply this the same way to the cluster, which will configure the config map that's just a default with nothing in it, so it wouldn't work. But to get our changes into the IAM authentication, we will need to do a restart of the daemon set. So we will just do a rollout restart daemon set for AWS IAM Authenticator, which will restart the IAM authentication binaries in the cluster, so it picks up the new config that we just put in the cluster. So let's see our load balancers in the meanwhile, if they have been provisioned. So we can go to the address, for example. Let's see, I believe this is the service load balancer that we have, which correlates to the service with the load balancer type. So we can get this URL, and then when we hit it through our browser, it's going to give us our request, that the simple request information and some server information. This is just a demo. You can use your any like domains, host names through this. Since we don't have a custom domain for now, I'm just configuring the service to go through just the AWS domain. But you can use your own domains and configure your ingress in that way. So in here, for example, when we can check, you can say your host is something else, but I just, for the sake of the demo, we use the default domain that AWS gives us. So let's see if the other load balancer is also provisioned. It's going to take a bit. So in that time, we can try our IAM authentication. So we will need to configure a kubeconfig file to use the IAM authentication. So the CloudFormation template in here installed a binary which is called AWS IAM Authenticator, which does the whole webhook, go to the API, verify this, and get a token process. So we need to install this if you want to use AWS IAM authentication. This will need to be installed on any of the clients that's going to use this. So basically, in that sense, we will again have a template kubeconfig. We will can take a look at it. So we will have to configure this with the endpoint, the certificate authority, the cluster ID, and the role arm. So the simple ones we can do is, let's change this with MicroK8s, since we created the CloudFormation template that way. Our cluster name is MicroK8s, and for the role arm, again, I can get it through our formation template. And let's save this. To configure the endpoint, we can check the default values. The MicroK8s kubeconfig has. To get that, we just do sudo MicroK8s config. So it will give us a kubeconfig that will have the authority data we need and the server information we need. This is usually the private IP. So if you have like any load balancers or anything in front of it, you will need to adjust this accordingly. So we will start out by copying our certificate authority data here. So let's save that, and then I will also pick up the endpoint. So in here we can put this. So our kubeconfig file is ready. I have a separate kube control binary, which is from the snap install kubectl classic. This is different from the sudo MicroK8s kubectl. MicroK8s kubectl is pre-configured with the configuration we just saw. It uses a wrapper to configure the kubectl in a correct way. So this is going to be a different binary without the pre-configurations that MicroK8s provides. So to use our kubeconfig, we can just say export kubeconfig and let's say through our user at YAML. So we have this exported, and if we use this and we just got a response through the IAM authentication. So I can explain what this kubeconfig does. Is basically we can see here that it will just have the cluster information, and then it will have a config. It will say a user named AWS will do an execute to verify or like get a token. It uses the AWS IAM authenticator we installed in the node or like the clients. So this binary basically, and then for arguments it will pass the cluster ID and the role arm. It will get a token with this command. So it's basically calling this command, getting a token, and sending it to the API server. API server in our cluster is asking the IAM authentication pod in here to verify the token, and if the webhook succeeds, we get a response. If it doesn't, we will get a error response. So in that way, we can authenticate through IAM. This can be done for multiple users, multiple roles. So this is not just pre-config, like this is not just limited to the single role we have or a single user we have. There are documentations for each of these add-ons in the MicroK8s AWS add-ons page. You can check that. They have links to the upstream Helm projects, Helm charts that they use for more details. And lastly, we think we can check the ingress. So it gets a application type of load balancer, which is corresponding to the ingress we have under our Echo Server deployment, which we can see. Get the URL to verify everything's working correctly. And when we go through this URL, it's going to respond to us. As you can see, this has two different responses. Maybe I can zoom in a bit more. So one of them goes through the ingress and has the added ingress headers, and this one just goes directly through the network to the pods themselves. So this is their main difference. This is basically it. If you have any questions, feel free to ask, and thank you for joining to this session. So let's say, any questions?
So thank you, Berkay. So very good presentation or sharing of the demo. I'm wondering if there is a kind of instruction software that people can go and read how to make this setup.
Yeah, the demo repository, we have linked to the slides. We can share the slides, and I will add a README file there with the instructions that I just explained. So I think next week you can find the README files there with the instructions.
All right, thank you. Any other question, or we wrap up over here?
How good for me. Thanks for the presentation. Good job.
Thank you for joining.
Thank you, Pedro. All right, thanks a lot, and see you next Friday. It will be like an opening session for any type of discussion. We are, if you want to interface our experts, and the Friday after, so we are going to have another sharing session. So as we presented in the calendar. So see you in next Friday or 2 Fridays from now.